All right. Welcome to the third installment of these 4.5 notes, solving polynomial equations. Again, if you haven't watched the first two parts, I guess depending on where you're at, maybe you were in class for the first two and just need to catch the third. It's up to you. But there's just make sure you know that there's two other parts you can kind of see here as far as just looking at the slides that we've done. This lesson was no joke, and that's why it's broken up into three parts. So if you need any of that stuff, you should be able to find two different parts 1 and part 2, depending on what you need. We're up to this last one now. Luckily, hopefully, for everybody's sake, including mine, this should be the last one should be the shortest. You can see there's one quick note and then two examples. All right, so enough's enough. Let's do this. We can do it. All right, home stretch. So first thing here, we're jumping right to it. So obviously, this is part 3. Everything else you should have, you can find in other sections. Heading: irrational conjugates theorem. What the heck do all those words mean? So there's a couple different things here that make sure, and this is the Mr. Kroll summary. The essentially is usually just me summarizing like what the book says. Essentially, irrational zeros will always come in pairs. And the pairs are what we call, the pairs are conjugates. But there's a ton of vocab in there. If you don't know what's going on with that, that doesn't mean much to you. Okay, so even further kind of simplifying that, long story short, whatever you want to say, irrational, remember, is we talked about in the previous section. That's stuff that involves a square root. Okay, just the square root of a number. That's what's called irrational number. And then remember, a zero for us, for the most part, means like solutions. Okay, and then conjugates basically means like opposite signs. Okay, and we've seen this already. I could scroll back up through here and find it. Well, actually, it's probably not that far back. Maybe we should. We came up with two irrational solutions here. One plus the square root of 3, one minus the square root of 2. That's actually a perfect example that illustrates that if I come up with a solution that has a square root in it, it's going to come in a pair, a positive and a negative version. That's a perfect example of it. We can put a couple more here because maybe you didn't watch that section, or you already have that in a different section in your notes. So examples would be, and they don't have to have a +1 in front of it, but that was just a good one to look at. There was another one I could scroll up to that we never solve an equation. Let's pick an easy one. That if it was this was the one I think we solved earlier. That if I were going to solve this, what are my two solutions? X equals the positive and negative square root of 3. So maybe that helps with some of us. I know a lot of times we have a tendency to forget that there's a second solution there. So the positive square root of 3, the negative square root of 3, those are conjugates of each other. We just looked at one. We'll just put them up here as like an additional example. 7 minus the square root of 3 is one of your, well, let's use something different. Why am I using the square root of 3 over and over? It doesn't have to be the square root of 3. The square root of 7, if that's one of your zeros, if that's one of your solutions, you could write it this way too. 7 plus the square root of 7 would also be there. So that's what we're saying here with this note. Irrational solutions come in pairs, and the pairs are going to be opposite signs on them. And that's a little bit not true. Like 7 and 7 stay the same, but it's the square root portion that's opposite. Okay. Put a pin in that. We're going to come back to that in a second. Maybe I could have stuck that slide in between these. We're not going to use that concept right here in example 7, but we're going to pull it back in example 8. Okay. Here we go. Last two, and they're the same kind of setup. Okay. What this is like a true reversal of everything else we've done in this lesson, like a flip. So if we go back, and I'll try to find like a typical one. How about this one, that really big one? We finished this problem. We said our solutions, or maybe let's find out what it said. Find the zeros. Okay, find the zeros of this. What were our zeros? I like this one better. Sorry, I know I'm jumping around a little bit. This could have said find the zeros of this. What were our zeros? What were our solutions? -1, 2, 8, and -5. Okay, so the problem that we're going to work on now is we're going to start right here. I'm going to give you these 3 things, or 3 or 4 or whatever things, these 4 solutions, and then our job is to basically reverse this process from this to 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 this, and end up with like this as an answer. Okay? True reversal, right? On this example, we started here and ended here. What we're about to do on this one is we're starting with some zeros, and our answer is going to be a function, a polynomial function, okay? All right, so that's kind of what we're doing here. Let's get to the process of it, all right? So some of this stuff is just like stock phrase. When it says, I kind of just described it. We're going to write a polynomial function. It's telling us to, in the end, call it function f, okay, of least degree that has real coefficients and has a leading coefficient of 1. Don't get super hung up on that directions. That's just going to happen as far as like how we're going to do this. But also understand that like -3, 8, and 9, there's more than one function that those could be the zeros of, right? Like there's not just one universal polynomial that, yep, there's only one that these actually are the zeros for. There's an infinite amount. So this is kind of just saying keep it small, keep it simple. Yeah, so that's what that's saying. Here's the process. If these were my zeros, right? If let's truly reverse this. X equals -3, X equals 8, and X equals 9, right? That's kind of what this is saying. We've got 3 zeros for this one, -3, 8, and 9. What would have been the step right before that probably? And it varies, obviously, problem to problem, but a lot of times it would have looked like X plus 3, like kind of written as factors, right? X minus 8, and then X minus 9 equals 0, right? So then we would have looked at this and said, oh, yeah, this is easy. I can look at these and say, what are my 3 solutions? X equals -3, X equals 8, X equals 9, right? So there we go. We're already reversing it. And actually on this one, maybe you can already see kind of where this is going. What would have happened right before this step, right? We would have probably unpacked something, like factored something, and would have ended up with stuff that looks like this. So how do we unfactor something? We multiply it out. That's essentially what we're doing when we're factoring. We're dividing these polynomials. So why don't we just multiply this out? And that's exactly what we're going to do. Okay, so this is a skill that we're actually all pretty good with. I've seen us do this a lot of times. We multiply these out. Just take 2 at a time. X times x is x squared. X times -8 is -8x. 3 times x is 3x. And 3 times -8 is -24. I don't want to go too fast. I don't want to screw this up. So we combine our like terms. 8x squared, or I'm sorry, x squared, looking at the 8, minus 5x, minus 24. Geez, struggling already. Minus 24. Oh, I switched mid-color. Switch color mid-problem. Now again, just don't forget, hey, this is how we do this with 3. We got to bring that next one down, and I've got another round of multiplying. So here we go. Let's go x squared times x, which is x to the 3rd, minus 9x squared. Let's see, going this way now, minus 5x squared. They should all be lined up and right next to each other, which I think making in the end, combining them should be kind of nice. 45 x, sorry, I'm talking too much and missing some of this stuff, minus 24x. Oh, here we go. Big one here. I'm going to double check it. I think I could do it. But was it 216? Let's double check. I want to make sure that that's right. -24 times -9. Yeah, positive 216. But I'd hate to make a notes video where something in the video is wrong. All right, so we multiplied them all out. Did I multiply -24x? Yeah. Last but not least, combine all this stuff. So we've got, in the end, x to the 3rd minus 14x squared, 45x. Again, just double checking. 45 minus 24 is 21. X, and then we've got this positive 216 hanging out at the end. Believe it or not, that's exactly what the question asked us to do. I'm just going to slide this over a little bit because it bothers me if that f of x. So just finish it now by, what did it say? It said, well, let's go back and look. It said, write a polynomial function f. So call it a function. Like, let's not just leave random stuff hanging out. That's an expression there. F of x equals, there we go. Now we've got a function. F is a function of x. Big old numbers here, coefficients, whatever. least degree, it's a third degree, real coefficients. So like I said, don't get hung up on that. That's all just going to happen. Leading coefficient should be 1. And I promise you, if we start this problem and try to find the zeros, here they are, -3, 8, and 9. Just as a quick review, I'm not going to do this whole thing, but how would you start this? Oh, I'd start with synthetic, and like you'd look at, actually you could probably factor by grouping on this one. But so yeah, it's reversing that process. Okay, so that's our answer for that one. That's not bad. Like, that's pretty doable. What makes this one nicer than the one we're about to do? These are all nice and clean numbers. -3, 8, 9. Right? So you jump right here. Last one. Okay, same setup, like we're being asked to do the same thing, but this is going to make things not so nice. So now we got to come back to that irrational conjugate theorem. Okay. So the first thing, as I'm reading through it, write a polynomial function f, least degree, real coefficient, blah, 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 blah. That's all going to happen. Okay. What are my zeros? Okay. X equals 2. I'm going to just rewrite them out here so I don't screw this up. So it's telling my zeros are 2. This is all 1, 0. Some people write like 3, and then they write like -√3. That's not what this is saying. There's no comma there. Like, this is one of my zeros. This is another 0. 3 minus the square root of 3 is another one of my zeros. And basically, I'm checking, do you know that, hey, yeah, what did we just take the note on? These irrational ones with these square roots have to have a partner, have to have a conjugate. So even though it's not listed there, I need to make sure, this is me checking, do you understand that? There's another one that's not on this list. It's 3 plus the square root of 3. So that's the first one. Make sure you account for any ones that are maybe purposely left off that list, because of the, we know they got to come with a pair. So that's first part. Get them all listed out. What did we do on the last one? So after we listed them all out, we wrote them as factors. That's the part that's the people struggle with sometimes. Not the x minus 2 is no problem, right? This is going to be x minus 2. It's these other two. How do I do this? So I'm going to try to give you something here to make this like automatic. Always start your zeros your factors as x minus. Okay? Whatever you see, just start them as x minus. In that actually applies here. We didn't do it, but I could have started this with, all right, Mr. Crow said I always started with x minus. So what are my zeros? -3. Mr. Crow said started with x minus. What are my other zeros? 8. And then Mr. Crow said started with x minus. What's my other zero? 9. And we would have ended up x minus 9, x minus 8, x minus -3 is +3. So if I kind of follow that process of always started off as x minus, it's going to be x minus, what's my whole zero here? It's this whole thing we said, right? So it's got to be actually, and here's where it gets kind of messy. X minus this whole thing, 3 minus the square root of 3. And there's actually, I've kind of put a parenthesis within a parenthesis. That's where it gets messy. All right, Mr. Kroll said, always start my factors with x minus, and then subtract whatever the whole thing is. And again, it's this whole thing. So parenthesis 3 plus the square root of 3, close that parenthesis, and then close the original big one. So now all of a sudden it's like, wow. Look at all those parentheses. Look at all those square roots. Like, I don't like that. Okay. But that's just how we're going to have to start this one. All right, we're going to tuck this x minus 2 away, and we'll come back to that end. That one's just so nice, like it's whatever. At the end, we'll multiply by that one. So don't forget about it. Don't let me forget about it. I don't know how you're going to do that, but yeah, I'll make sure we come back and get that one. Okay, let's take care of these things. I don't like that inner parenthesis. Let's get rid of it. Can I just erase it? No, but it's a simple, like, let's just distribute this minus here and here, and then at least just be down to like, all right, it's x. I distributed here, so it's -3, and then I distribute over here. It's going to switch that to plus the square root of 3. And then we'll do the same thing on this one. We'll distribute, so it's going to be x minus 3, and then minus the square root of 3. And I bet a few of us are like, what the heck? You're right back where you started. 3 minus, you just kind of flip-flopped them, right? But one thing's kind of different there. It's minus 3. These were both plus 3. So there's a little bit there. Just, again, stick with the process a little bit. You kind of got to have faith in that, I think. Just distribute that. Start with the double parentheses, and then it's just a fairly simple, just distribute and watch your signs. Okay? From here, let's multiply this. So it's this weird kind of triple FOIL, or whatever you want to call it. I'm going to try to color code it, so I'm going to slide this over here a little bit. But yeah, multiply it out. Like, that's kind of what we're doing here. So the biggest thing I would say is probably organization. Just keep track. Don't try to cram this into the corner of of your notebook or whatever. X times X. Draw the lines like you hopefully, or maybe you learned it. X times X is X squared. No problem. X times negative 3, again, no problem. So far, so good. Okay, be careful here. X times negative square root of 3 is negative. I would write it as X square root of 3. Keep them separate. Don't stick that X underneath the radical. Okay, and just, again, watch your signs. All right, let's go to my next one. Should have to be drawing 3 lines. I got another 3 times X, or I'm sorry, negative 3. I said it wrong, but negative 3 times X, so negative 3X. I'm going negative 3 times negative 3. That's just a nice, awesome, positive 9. And then again, watch my signs. This is negative 3 times negative square root of 3, which is actually going to be a positive 3 times the square root of 3. I think we're okay there. I don't think we made any mistakes. Last round of it, maybe come underneath here just so you don't miss it. So it's positive square root of 3 times positive X. I'm going to write that as positive X times the square root of 3. We've got positive square root of 3 times negative 3, so that's going to be minus 3 times the square root of 3. If you can't tell, I'm taking my time, not just simply because to make the notes easy, but so I don't screw anything up. Not just for the notes, like, it's easy to lose a sign. So I've got positive square root of 3 times negative, so a positive times a negative is going to be a negative. And this one's unique. We haven't seen this. What's the square root of 3 times the square root of 3? It's the square root of 9. We can actually put those together, and we should put them together. Well, at least the parentheses are gone, if that's if you're looking for a silver lining here. It's not as bad as it looks. As long as we've taken care of what I think we've taken care of, certain things are going to happen here. There's stuff that's going to disappear. So take a look here. I've got a negative. Focus on the ones with the square roots for right now. I've got a negative X square root of 3. I've got a positive X square root of 3. What's a negative plus a positive, or what are opposites added together? 0. They disappear. Oh, okay. So we're shrinking it a little bit. Let's find another square root one. I see a positive 3 square root of 3. I see a negative 3 square root of 3. Again, we're adding opposites. Those disappear. So kind of not magically, but conveniently, all those square roots are starting to disappear. I see one more square root on my screen, but what obviously everyone's seeing it, and you're yelling at the screen again, saying, scroll, the square root of 9 is 3. So this is just minus. Don't get rid of it, but make sure you know that, hey, that's just minus 3. That should get combined with any other whole numbers, or not any whole numbers, but any other nice numbers. So when that big FOIL, that kind of nasty triple FOIL is all said and done, there's a few to combine, but they're kind of our more traditional things. I've got an X squared. Nothing to combine with that. Let's switch over. I thought I switched to green. X squared. Awesome. I've got a negative 3x and a negative 3x. That's negative 6x. Okay, and then just don't miss. I've got a positive 9 here. I've got a minus 3 here. When I add those together, I get a positive 6. And I sigh, not a sigh that I'm tired, but a sigh of relief, like, hey, we end up with something that's fairly benign looking. That looks pretty innocent. You'd never guess by looking at that, hey, if you got a quadratic formula of this, you're going to get 3 plus the square root of 3, 3 minus the square root of 3. Those are the, if we were solving this equal to 0, those would be the solutions. Oh, okay. That's a beast, right? That takes a little bit. That's going to take practice. This part, there's a setup portion that I think is kind of tricky. So go back, rewatch. Always started as x minus, use that double round of parentheses. We're not done, but I think we're out of the woods here a little bit. I'm not going to forget about this. But again, watch that setup part and take your time. Go deliberate. Watch your signs on this part of it. Okay? In the end, all the roots should disappear, and we're left with fairly clean numbers. All right, last part would be to multiply. If there's anything there, maybe that was the only 2 zeros. Okay, so I'm not saying there's always going to be something there, but in this case, yeah, we had this x minus 2 that we still just earn it. We still have to kind of multiply out. But again, this is going to be your more traditional, like we did on the previous one. Okay, so we're going to end up with x squared times x, which is x to the third. Don't screw this up, Mr. Crowley. This is your last one. I'm just psyching myself up here a little bit. Minus 2x squared. What else we got here? We got negative 6x times x, which is negative 6x squared. And then I'm going to come all the way over and go positive 12x. One more. Can we do it? Plus 6x. And then minus 12. Let's combine what needs to get combined. I'm going to start it here as f of x because I know that's what it's said to do. Call it f. X to the third. 1, 2, 3. Nothing to combine with that, right? We're good. I've got a negative 2x and a negative x squared, sorry. Negative 8x squared. 12x and a 6x. So we're talking 18x. And last but not least, negative 12. Now there's a sigh of relief. There's a sigh of exhaustion. We did it. Okay. Kind of joking a little bit, but yeah, they can either be like the previous example, not so bad, or they can get a little beastly there. So go back, rewatch. That's kind of the only example I have set up like that. Rewatch what we need to. But that'll do it. Maybe this, like I said, I think that ends up being the shortest of the 3. Use the irrational conjugates theorem. We certainly did that on that last example. Lesson 4.5. That's as long as we've ever had. So we are done. 4.5 in the books. I will look forward and I hope to see you in future lessons.